Hello students, welcome back. Now the final topic here is a continuity of piecewise defined functions, and we went through the first half of it. And the second half is going to be a little bit harder. Previously we went through a piecewise defined function, completely defined, and we went about how to check the continuity. But this time the function is not completely defined. We have undefined parameter a and b, and we want to determine those so that this function is continuous all the way. It says continuous all the way, but there are only two possible breaking points to worry about: x equals to 1 and x equals to 3. So basically, if I plug in x equals to 1 and compare the first and second line, and plug in x equal to 3 and compare second and third line, we're going to get two equations. One at x equals 1 and the other at x equals 3. Two equations and two unknowns, a and b. I can solve it. How to solve? That can be a bit tedious, but here it is anyway. Plug in x equals 1 to the first line and the second line. These two have to be the same. So setting those up, and we ended up with a equals to -2. Next, let's plug in x equals to 3. Second line and third line. And these two have to be the same. We end up with b equals to 4. Why didn't I make it bold? So a is -2 and b equals to 4. Otherwise, the function has to be discontinuous. By the way, here in the second line, here in the third line, this is coming from the second line. In the second line, plugging in x equal to 3, the a value here is -2 because we found it, and that's why we are getting -6 here. Eventually, we get this kind of visualization. But this problem was exceptionally simple. You see, plugging x equals to 1 and setting these two equal, we ended up with one parameter value directly, and we were very, very fortunate to get this. Most of the problems are far more complicated. How about this? Plug in x equal to -2, then you're going to get the first line and the second line. So that's going to be one equation. And then plug in x equals to 1 to the second line and the third line. Set those two equal, we get another equation. Two equations and two unknowns, we can solve it, but this time it's going to be far more challenging. Alright, put x equal to -2 to the first line and also to the second line. You see, first line and second line. Excuse me, maybe I should do this. Blue, blue, red, red, green, green, all right. Now this is blue. This is red. Coming from the first line, from the second line. And I have to set these two equal at x equal to -2. And then a bit of a simplification, we ended up with an equation. But we cannot solve it. We have two unknowns and one equation. So we need another equation and set up a system of linear equations to solve it. How do I do that? Put in x equals to 1 to the second line and third line. So that's the second line, and that's the third line. Plug in x equals 1 there, because 1 is the other possible breaking point. Setting these two equal, this and that, we get this equation. And then after simplification, we get this. So we get 1 star and then 2 star. And these two will give me a system of linear equations. These two. And then how do we solve it? Well, there are many ways to do that. Elimination and substitution. Looks like I used elimination here. Eventually, it'll turn out that A is 5 and B is B is 7 over 2. And we end up with this kind of graph. These kind of problems are very, very comprehensive in a sense that you have to review a lot of things. You have to go back and review those piecewise defined functions, and then the idea of limits, what to plug in, how to set up equations, and then how to solve those system of linear equations, and so on and so forth. So if I have a lot of mathematics majors that have to review all those and know all those techniques thoroughly, then I'll emphasize this kind of problems. But otherwise, not very much actually. So that's where I'm going to stop. And I'm not going to emphasize section 5 too much, I promise. Even though I cannot promise I will just completely remove it. There is some chance it may show up, but it's not going to be too much. And even if it does show up, it's going to be too difficult. Anyway, we are done with continuity of piecewise defined functions, and we'll say we are completely done with section 2 as well.